Morning. So we are going to get even fancier today. So we've been doing a lot of rewriting logs and exponentials. So we're going to kick it up a notch, just a little bit. We're going to gradually increase what we can do with this stuff. So we're going to learn something today called the change of base formula. With logs, you might be like, this is super weird looking. Like, I could never solve something like this because one, how the heck do I put it in my calculator? And two, what are all these random nonsense that we do? So this is where the change of base formula comes in. So the change of base formula. So when we can't figure out like what that pattern is, where we had like the 2 times itself 3 times would give us 8. When we have like a weird decimal or something, this is how we would get that. So just a reminder, remember if we have the log base b of y equals x, remember this is how we change it. We circle our base is always at the bottom, and we move it to the other side because we're finding the exponential, our log falls. And so we would have y equals b to the x. So normally when we do this, we're like, oh, that makes sense. I can figure out that number. Well, what do we do if we can't figure out that number? So what we want to do is we have our log base b of y equals x. The way we solve it, our change of base formula, is our b stays at the bottom. It's our base. So we can still figure out what x is by dividing. So we have log of y divided by log of the base equals x. So notice how these don't have bases here, because bases are like super hard to write. We figured that out when we were trying to do Desmos. We're like, oh my gosh, I need to do shift underscore, then the right arrow, and it was all crazy. With this, it's a little bit easier because our base is that 10, where we don't need to write it, it's just assumed. So we would just have log of whatever's on the top, remember our product, divided by log of our b or our base, and that would be whatever our solution is. So what that looks like, for example, say we had log of 16, base 16 equals 32. Well, we're used to circling and moving and finding the x and like rewriting and seeing if we can figure it out, but this isn't going to give us a pretty number. So let's rewrite it. First, I need to look for my base, the same as always. And instead of changing my formula to be exponential, I'm going to use this change of base. And I'm going to have log of my top, which is 32, divided by log of my bottom, or my base, which is 16. So you can put this in your calculator. So you'll notice in your calculators, if you flip it sideways, it'll have the log button in it. So that's where it brings your scientific calculator. So you'd write log of 32. Then you want to make sure you end parentheses if it starts parentheses. Then you want to divide it by, then you press log again of 16 and end your parentheses. So it should look something like that in your calculator. Then when you press enter, it will give you your answer, which is 1.25. So that one wasn't like our 2 to the 4th power equals 16 or anything like that. That was like that 3 halves we had, that tricky one. So if we're given a log, we can do that. We can also do it if we're given an exponent. So say we have 3 to the x equals 10. Well, thinking in my head, I know 3 to the 1st power is 3, 3 squared is 9, 3 cubed is 27. Wait, what about 10? Well, this is going to be a decimal. So we have to solve. Remember, this thing is the same thing as saying 10 equals 3 to the x. These are the same thing. So if you're used to drawing your circle and moving one way or the other, you can always rewrite it. So I'm going to circle my base and move it to the other side. So all I have left on this side is my x equals. Now my 3 is going to be the base of my log of 10. Now I use change of base. My base is 3. I already learned that from over here. So I'm going to have x equals log 10 divided by log 3. I put that into my calculator, or I literally just Google, if Google's not down, log 10 divided by log 3. Or you can use your Desmos calculator and put in log 10 divided by log 3, and it'll give you x equals 2.096. So for these, I always want you to go to the 4th decimal place, and there's a method to my madness. You'll figure out why I'm doing that a little bit later, but you always want to go to the 4th decimal place. So you want to have 4, that's only 3, sorry. You want 3, so you want 3 things after the decimal. We're gonna do one more example. This one's a little bit harder. So say we have 9 raised to the n plus 10 equals 78. So we're like, but there's a bunch of stuff here. So we have to be careful. We can still do the same thing. So I look for my base. My base is 9 because it's on my bottom. And I move it to my other side. Now I have n plus 10 left over here equals, I have log, my base stays the same, it's my 9, of 78. I now use my change of base, so I'm doing nothing to this side. I'm just rewriting it because I'm not doing anything to it. So I have n plus 10 equals log of 78 divided by log of 9. So that base goes to the bottom. I put this part into my calculator. So n plus 10 stays the same. I haven't done anything with it yet. I do log 78 divided by log 9, and I'd get about 1.983. Remember, I'm using 3 decimal places. Can I solve from here? This is going back to algebra. If I want to get this alone, I can just draw my little line. To get rid of the adding, I would subtract. So I subtract 10 from both sides. So my n would be negative 8.017. So you can do tricky ones like this. There's just a couple more steps where you solve after you do your change of base. So we're going to do some practice with this now. Make sure you're asking questions. I know this stuff is hard, but you got this.